This is the case of sinus venosus ASD of SVC type, superior vena cava type. In this image, what you see, this is inferior vena cava, this is right atrium, then this is left atrium, this is right upper pulmonary vein, this is superior vena cava. Again, see, this is inferior vena cava, this is right atrium, this is left atrium. Just to I want to make nomenclature. This is right atrium, this is left atrium, this is right upper pulmonary vein. So in this image, what you will see, this right atrium, this is left atrium, is communicating with simply you see, this is superior vena cava, and this right upper pulmonary vein is also communicating with superior vena cava. So this is a type of ASD where you call sinus venosus ASD of SVC type. Just see. This is left atrium, this is right atrium, this is SVC. Right atrium is a structure that is receiving IVC and SVC. This is the most inferior part, this is most superior part. So the inferior part IVC and most superior part SVC. This position is sagittal plane. This is most anterior, this is most posterior, this is most inferior, this is most superior. So superior part is having superior vena cava, inferior part is having inferior vena cava. Now the next image, again you see this image. In this image you can see this is IVC, this is right atrium, and this left atrium is communicating with right atrium through SVC. You see how the blood is going. You can easily see, appreciate in this image. And you can see the right upper pulmonary vein is also communicating with SVC. See, this is the flow from left atrium into right atrium. This is flow from right upper pulmonary vein into superior vena cava. So ultimately, the venosus ASD is that if superior vena cava type venosus ASD, in that case the blood is going along the flow of superior vena cava. If IVC type of venosus ASD, in that case blood is going with the flow of inferior vena cava flow. So this is the case of sinus venosus ASD of SVC type. So blood is going through superior vena cava along with superior vena cava. See, this is left atrium, this is right atrium. Blood is going from here to here. But how this view was obtained in this case, you have to keep the probe in sagittal plane. Sagittal plane, obviously bicaval view. Bicaval view means you have to see both the vena cava in one view. That is called bicaval view. That is the view obtained in subcostal plane, placing the probe sagittally. So you are getting the sagittal, this is sagittal image, and making a displacement of probe towards little bit cranial displacement. That means from subcostal towards external region, you see. Then you will get this kind of view. Now you can clear this blood is going from left atrium into right atrium, and blood is also going from right upper pulmonary vein into SVC. So this kind of ASD is always with partial anomalous pulmonary venous connection. Partial is why? Because only one pulmonary vein is draining into right atrium through SVC. You can easily see in this image how this right upper pulmonary vein draining into SVC. See again the same thing. You can clearly see left atrium into right atrium. This is left atrium, this is right atrium, this is SVC, and this is right upper pulmonary vein. I've seen the moving image. You can easily see the right upper pulmonary vein is draining into supra vena cava. So this is sinus venosus ASD of SVC type. So how do you obtain this image? You obtain this image in subcostal region, place the probe sagittally. So the image comes sagittal image. Bicaval view, just make a movement of probe cranially, cranial movement, that is from subcostal region towards the sternal region. Little bit movement will give you this image. You can easily find out sinus venosus ASD of SVC type or either IVC type also. But as IVC type is very rare, SVC type is commoner than IVC type. So you will get SVC type of sinus venosus ASD. This is IVC. Opposite of IVC there will be this is SVC. This is left atrium. In this image, this is right atrium. This again this IVC, right atrium. This is left atrium. Thank you.